Okay, well, welcome everybody, and thank you for coming to today's webinar on how to test TR-069 enabled devices. A lot of the webinars in the past that we've done on this topic have been focused around specifically how to do these things in CDRouter, as in building configurations and going into some of the in-depth features of CDRouter. Well, we will be talking about the best way to test it using CDRouter and how the best way to automate such things. This is going to be focused on more of a higher level, what sorts of things about TR-069 itself are important and why you should test those things and how to test those things. So if you are sort of intimately familiar with TR-069 already and or intimately familiar with CDRouter and you find that this is redundant, that's fine. We'll have other resources at your disposal, but this is mainly targeted at people who are either new to TR-069 or new to CDRouter and want to know how to the best things to prove about a TR-069 device. So my name is Jason Walls from QA Cafe, obviously the makers of CDRouter, and I'll be going over a couple things with you today. We're using a system called GoToWebinar, so if you do have any questions during the webinar, you can ask them in the little control panel in the bottom right corner of your GoToWebinar control panel there. There's a question box. And if you have trouble seeing any of our demo screens, you can use the zoom feature of GoToWebinar's window to zoom in if that ends up being too small, because we'll go over some test logs and that kind of a thing, and the text might be a little tiny. So what are we going to go over today? I want to go over the basic components of TR-069 so that I can give you a description of what sorts of things should be tested and why, and that actually goes pretty deep. We'll go over what some of the common TR-069 issues there are and what sorts of things you should test to resolve those issues. We'll go over why it's better to use a simulator instead of a real ACS. We actually get a lot of people saying, I need to test with so-and-so ACS, and while that will give you good interop results, it won't prove a lot about your TR-069 stack or test for certain things like negative test cases. And so I want to go over some of the caveats with that. Then I'm going to talk briefly about TR-069 certification and how it's different from other TR-069 testing you might be doing. And then lastly, I'll quickly go over the CDRouter tests that we have for TR-069 and the BBF.069 add-on. So this is the TR-069 architecture, and the reason why I brought up this diagram is because I want to talk about the kinds of interfaces that we're talking about when we're talking about testing TR-069. Obviously, you could do a lot of interop testing between an ACS and the things on the right we call C2MP endpoints. You could do a lot of interrupt testing between ACSs and the CDMP endpoints, but when we are trying to test the protocol stacks of those endpoints, we're really talking about this interface here and how it interacts with the simulated ACS and how it correctly or incorrectly implements the protocol. And then also about managed devices on the LAN. So those are the devices that might use different aspects of the data model. They might use some of the service data models. And they either have a direct connection to the internet and therefore a direct connection to the ACS, or they have to go through the broadband gateway, in which case incoming requests like connection requests might be blocked by a firewall or by network address translation. And there's certain ways that you have to get around that in order to do TR-069 testing. So this is the protocol stack direct from the TR-069 standard. And I brought this up here to talk about the different things that should be tested from the bottom up. So there'll be things about session management. That's sort of the last three blocks there. So first we're going to talk about testing aspects of a TR-069 session. We're going to talk about validating that the TR-069 messages are encoded in SOAP correctly and that they are validated against the XML schema defined by xmlsoap.org and by the W3C. And we'll talk about verifying that the basic TR-069 RPC methods work and are implemented and how to go about using them. And lastly, I want to talk about what's really under the surface. So we talk about the CPE or the C2MP endpoint management application. So that is the system that is using TR-69 to interact with the TR-69 system, but really underneath is using it to make actual changes to the device. And that's really comprised of the data model, and that's both the supported data model and the instantiated data model. And the supported data model is a description of what a device supports versus a description versus what the device is actually implementing at the time. So the supported data model is either specified by referencing an actual data model, either by hand, by spelling it out in text form, saying what you support, or by implementing what we call a device type document, which is defined in TR-106, which allows you to import aspects of a particular data model and say what a device supports. Or it's done by referencing profiles, which are found at the end of a data model, and I'll show you a little bit about those later. The instantiated data model, on the other hand, is what is actively being modeled by the device at the time. So it represents its current configuration and the current objects that exist and the parameters and their values that exist and things that have been changed during the course of TR-69 operation. And then underneath that is the API to the device that TR-69 is using to interact. So obviously this is where the secret sauce and proprietary things of a particular device come in, how it's interacting with the underlying components. So we want to test not only that TR-69 is able to work and edit a configuration, and that the instantiated data model changes, and that those changes are reflected and then read back to the ACS. But we want to make sure that things actually occur. We want to make sure that if you set up a port mapping through NAT, that port mapping is then going to actually forward traffic. We want to know that when you create a new Wi-Fi SSID, that it's actually created and devices can connect to it and traffic can pass and that kind of a thing. So let's start with a TR-69 session. So this should be a familiar diagram for those who have looked at TR-69 before. And this really reflects all aspects of a TR-69 session. And that includes establishment of the secure connection itself. It's a big area of problems when it comes to TR-69 implementations. Verifying the inform itself. So every TR-69 session starts with that lower layer establishment, and then the very first message sent from the CPE or the CMP endpoint to the ACS is the inform RPC, and it contains an event that describes why it is that it's connecting. And then the ACS gives a response. And once that has proceeded, the TR-69 session is now open. And that session does not complete until both the endpoint and the ACS send empty messages. And from the CMP endpoint side, that's an HTTP post. And from the ACS side, that's an HTTP response. And that indicates that they both have nothing more to say to each other, and that the TR-69 session can be terminated successfully. There are other things that specify why it should terminate unsuccessfully, and those are still spelled out in the specification. And there's other things to do with how TCP is supposed to be handled if you're going to be doing a session over multiple TCP connections. If something happens in the middle of an active TR-69 session, there's things in the specification that define how that should work, and those sorts of things should be tested too. So that's really everything we have on this page. So you want to, the things about TR-69 session establishment that you should test include connection request. And while there's many different reasons why the CPE will contact the ACS, in the context of testing, the connection request is the most useful, and it's also one of the most important things because it's a source of a lot of issues. So you want to test the functionality of connection requests. We tend to turn off other types of messages like periodic informs during our testing to make sure that it doesn't interfere, and we use the connection request in order to control that the CPE will talk to the ACS, the simulated ACS, when we want it to. Then we want to make sure that we test TLS and the establishment of the secure connection. And if you happen to use certificates, that the certificates are valid and that invalid certificates are rejected and all sorts of security things at that level. You then want to go through and make sure that the messages themselves follow the basic rules of the CWP schema and the SOAP schema, and the sort of the schema of schemas, the XML schema defined by W3C. And that can be done using XML validation. And if there's problems there, then you're probably going to see problems with the basic session establishment. If an ACS can't understand that initial inform, then it's it's going to reject it, and you won't be able to get that session established in the first place. So we talk about the inform RPC there. You want to make sure that the forced inform parameters are included, and then also that the basic HTTP messages are compliant. Usually that's not too much of a problem since you're using some off-the-shelf HTTP client or server to operate TR-069, and then that the TCP behavior is correct. Now I want to quickly show an inform. So you can see that we have the event that there was a connection request. We also see a value change here. It's possible that that value change is extraneous, which is something that you should also test for. But it's also might be there because there was a passive notification set. So you want to go through an inform and test that the parameters that are included here are the ones that are set for forced inform. So those parameters are defined in the data model. So whenever I'm referencing the data model, you can always go to the Broadband Forums website and go to TR-069 resources here. And this brings up this page. And this page has a reference to all of the data models and schemas that make TR-069 possible. And if you're building a device, you can use these files in order to generate your own data models and make sure that they follow the TR-069 schema, that the messages follow the TR-069 schema. But I want to go to device 2 really quick and show you these forced inform parameters. So here you can see the entire data model. See the forced inform parameters here. So you want to make sure that a device that implements device 2 at least includes these values in every inform. And if they don't, then an ACS is going to be wary of that. So a little bit more about connection requests. So they're used to trigger the CPE to contact the ACS, but it's the ACS that is currently configured in its device.managementserver.url parameter. And for the internet gateway devices, that would be the internet gateway device.managementserver.url parameter. And so this value is not related to the source of the connection request. So a connection request could come in from anywhere, but it'll contact the ACS that's in that parameter. And while that's kind of a nice accidental security feature, you should still test that the connection request is, the username and password is being validated, so there's not extraneous connection requests that could be made. And these connection requests are done over HTTP, but they can also be done over XMPP, and that was established in Amendment 5 of TR-069, and that's used so that systems that don't want to, that need to go around a NAT or a firewall can still contact the ACS. And for the effort of not making redundant systems, a lot of the ones that have chosen to use XMPP for LAN-side devices also use it for gateway devices. And then if you are using HTTP connection requests, they can be used in conjunction with STUN in order to get around that. So if you're going to have a LAN device that needs to receive connection requests from the ACS, that mechanism is defined in TR-069. So let's talk about basic RPC functionality. So this is sort of the next step in your in a robust test scheme for TR-069. The ones on the left are the ones that are required, and these are the ones that are necessary for TR-069 itself to operate. And if the CPE doesn't support any of these, it's not likely that they're going to be interoperable with an ACS. And some things about TR-069 might not even work. And so you want to make sure that these RPCs and the rules around them work correctly. The original PlugFest test plan that we use in CDRouter for some of our tests, known as OD128, covers a lot of these. And they're also covered by the BBF.069 certification program. And that includes both things that manipulate the data model, which includes, set and get parameter values, parameter attributes, add and delete object, as well as some of the basic CPE functionality things like reboot and download. And then on the right, you see the optional things. And obviously, if you support the optional things, you should test them. And that's sort of the difference between what we call in the certification program as mandatory conditional mandatory, where if you do actually support them, then you're going to need to test them. And this is also obviously deployment specific. So if your customer is someone that uses this in their system and has the ability to manipulate these things with their ACS, and then you're going to want to test for these things. The most complicated one here is probably change DU state, as it's a catch-all RPC for manipulating the software management features of TR-069, and that includes sort of installing new execution environments, installing new, we call them deployment units, but basically installing new applications, managing those applications and what state they're in, either installing them or uninstalling them. But that's just an aspect of the data model that is manipulated with this one particular RPC. So in the process of in verifying the functionality of the RPCs, you want to verify the validity of the device's data model. So the data models, IGD1, device 1, device 2, they all specify both the data type and the constraints on that data. So there might be certain ranges for numbers. There might be a list of acceptable enumeration values. There might be regular expressions that explain how a string should be formatted. There's some complex data types like MAC addresses and that kind of a thing. But those things are all specified in the data model. So you want to make sure that when you're doing get and set parameter values, that the CPE either responds with appropriate data types and ranges or rejects attempts to set values that are incorrect. And especially the last case, that data validation matters from a security perspective. We ended up running into some systems that will accept, arbitrary escape code into parameters where they really shouldn't accept values like that, and ended up running arbitrary code on them. That's called a code injection attack. And so that's one of the reasons that data validation is one of the most important things to test. And actually, I can show you an example of this. We actually have a TR-069 scenario. And so in CDRouter, we call a scenario, it's a generic test module that allows you to build your own test cases by, your own TR-069 test cases by doing particular sets and gets and telling CDRouter what to expect in return. So for this, I'll go right to the pass fail here. So for this, we actually set up a port mapping, and we test to make sure that that it rejects right here. We end up sending a bad value, and then it actually gives us a fault code of invalid parameters when we do that. That's one of the ways that we try to do data validation. But we also do that with so here's another example too. So we actually take in the baseline profile. This particular device has some custom parameters, but we ignore those as part of this unless you specify them in your CDRouter config. But we take this baseline profile and then we test everything that's specified in the profile. So if you go back to this, to the data model at the Broadband Forum site, and you go down to profiles, you start seeing some of these profiles here. So if you happen to implement the UPnP dev1 profile, these are the objects and parameters that you should support and the permissions that should exist on them. And so what we do is we take these profiles and then we go, so I'm going to click on this here. You can see that this is an unsigned int. These down here are strings of certain lengths. And so in the CDRouter data model validation, we'll go through and test to make sure that it accepts values that it should. So or contains values that it should. So you can see for here, these two parameters here, and it may just be an artifact of the fact that this is a new object and these things haven't been set yet, but they should be set. And so we can see here that they should have a value of, one of these enumeration values, and having no value is not one of the valid things. So we test to make sure that that data validation happens. So now let's talk about that underlying functionality validation. So at the end of the day, what are you trying to do with TR-069? You're trying to get the device under test to actually do what you configured it to do using TR-069. And that may be some TR-069 functional things, like either doing the reboot or firmware download RPCs, or making sure that it sends a bootstrap event when you change the ACS URL to sending it to a new ACS, making sure that when you change the periodic inform, that it occurs on the new interval after it's changed. But we also want to make sure that the device actually does what you wanted it to do. So if you changed an interface, do the statistics of the interface change? If you set a new IP address, is there a new IP address? If you set up a firewall rule, does it block the firewall rule? If you set up a port mapping, does it pass traffic through that port? Does it forward traffic through that port mapping? If you set up a Wi-Fi SSID, can clients connect to that Wi-Fi? So in CDRouter, we actually do a couple of these, and one of them is the TR-069 wireless test cases. And what we do here is we actually do a set parameter values to configure one of the wireless interfaces, right? We then verify that that those values were indeed set. And then we're going to go to, let me go to the pass-fail logs to shorten this. And we actually, we reset DHCP to make sure a new address is configured, and we send ICMP echo requests to make sure that that endpoint can actually be communicated with. So not only are we testing that TR-069 itself worked, but we test to make sure the device actually set up the new wireless configuration that you set by your TR-069 and it's actually working. So what's the difference between all this and the BBF.069 certification? The certification are a set of rigorous normative test cases. That means that they went through and combed through all of the must and shall behavior of the specification and developed a set of test cases around that, including things like negative test cases and sort of some edge cases. And that was developed by the Broadband Forum. And it's actually implemented using CDRouter by the UNH IOL, which is the Broadband Forum's certification lab for this particular certification program. And it's more detailed than the general interrupt tests, because those interrupt tests were designed specifically for people in a room testing with each other between ACSs and CPE. So that's why you're able to do a lot more things like negative test cases. And we include that in the CDRouter add-on. The BBF.069 add-on is used primarily for pre-testing before seeking certification, but it can also be used to sort of get a really, really in-depth analysis of your TR-069 protocol stack. So what are some of the problems? So we get a lot of people asking, if I test against this, am I going to interoperate with a particular ACS? And luckily, the answer to that is usually yes. But when you're evaluating your TR-069 stack, you want to make sure that you are actually using a tool and not an ACS, because ACSs are not designed to be test tools. So they're a little difficult to automate, and sometimes it's a question of whether or not you even have access to the ACS yourself, or you just have access to it over the internet to your customer. And whether or not you can actually script the test cases. Not every ACS vendor has gone through the effort of developing some sort of robust system of scripting test cases through their ACS. and whether or not you're able to interact with your existing reporting and integration tools. You have to kind of do that on your own. And then when it comes to custom vendor parameters, so if you end up having parts of your data model that you've built yourself, it's not necessarily the case unless you sort of set up the interaction ahead of time that an ACS is going to understand those things. Secondly, you can't really make ACSs do bad things, right? They are meant to work. So like when setting up a secure connection, they want TR-069 to succeed. And so you can't really script them to make bad messages or invalid messages or use incorrect certificates and that sort of thing. And that's stuff that you really want to test for. And then it's also kind of a pain to simulate other services, things like Wi-Fi clients that I showed you. So the FTP or HTTP file servers used in doing firmware downloads, setting that up ahead of time, setting up NTP, and having that sort of whole test environment in place. If you're just trying to use an ACS to be your test tool, you're not going to have those things. So CDRouter sort of handles this by creating a simulated ACS, and that ACS is active while the testing is going on and is sort of turned down as a service, just like all the other services that CDRouter simulates. But we also simulate the things around that are necessary for the operation of TR-069, so things like NTP and the file servers and DHCP. You can connect both, things that are designed for LAN side and gateways to CDRouter to do testing, and you can also do that together. So if you have a gateway and you have a LAN side device that's trying to talk TR-069 through a gateway, you can include that as part of the test setup. And then we of course simulate things on the host side, and that includes passing traffic, whether that's performance traffic or just simple ICMP traffic to make sure that a connection was actually established, or packets to make sure that a firewall is working or that port mappings are working. CDRouter sort of passes that stuff through, and then obviously there's the integration through the API with your existing test systems. So the types of CDRouter TR-069 tests include the original OD128 test module, and that was designed while the original TR-069 plugfests were going on. And it's mostly interop, right? So it was designed for people who were running an ACS and running a CPE to test with each other, and explores a lot of TR-069, but we sort of expanded that in the CDRouter TR-069 add-on with our own TR-069 module. And that expands on that, and it includes things like those Wi-Fi tests and other functional validation. And it also includes data model validation. So we go through, get parameter values on everything that your device says it supports, and verifies that the values are correct. It does set parameter values to make sure that it will accept values that are in the correct range, and also goes through every object that says it can have an object added or deleted and attempts to do those things. And that data validation is done using profiles, which I showed you before, which is interesting because there's many different ways that people in the industry have used to convey what a CPE supports. And while it's really later on, it was developed in TR-106 to create these things called device type documents to convey what your device supports. It's not necessarily supported by everybody out there as much as those at the Broadband Forum would like it to be. It didn't necessarily catch on as quickly as it should have. And so a lot of people still rely on profiles. And if you're building custom profiles, if you have vendor-defined parameters, you can build those in a file that we specify in a CDRouter format that we've made. And you can include that in your config, and then CDRouter will do data model validation on the objects and parameters defined there. Then we go into the extended data model add-on, which does data model validation, but it does it for the additional device types. So those things that implement service data models, like if I go back to the Broadband Forum site, you can see things are divided up into the root data models and the service data models, and the TR-069 EDM add-on applies to things like FAP service, which is a data model for femto access points, storage service, which is a data model for network attached storage or internal storage on a device, STB service, which is for set-top boxes, and the voice service data models. So EDM does data model validation on those things. The scenarios I showed you, those are customized RPC scripts, so you can set it up to say, I want to do a set parameter values on this object, and then I want to do a get parameter values on the same object, and I'm looking for the following values, and you can it's kind of an easy way around building a custom test case that is TR-069 specific. And then obviously the BBF.069 certification add-on. So, in review, the things you should test include the basic session establishment, and if you don't get past that point, then you probably have a lot of things to work on. The basic RPCs, and if you do implement them, the optional RPCs, and there is a lot to those. So, it's verifying that they use the correct error codes. There's rules around the status parameter if you're using set parameter values or add object, and the device needs to take time before it's able to implement it. It has to reboot, that sort of things. Those rules are all built into the definitions of the RPCs. Testing the data model and validating the data model itself, both reading and writing, and testing that real-world functionality to make sure your device actually does what you tell it to do with TR-069. And as we discussed, the BBF.069 add-on is used for robust pre-cert testing if you're going to be seeking certification. And it's always important to use a test tool capable of simulating the entire test environment instead of relying on an ACS. It's not going to give you the best test environment. Well, thanks everyone for joining us. And if you have any more questions, feel free to contact us at support@qacafe.com or sales@qacafe.com if you're not a CDRouter user. Or you can email us at tr69@qacafe.com with any generic TR-069 related questions, and I'll be happy to answer them. If you did miss this, we will be making a recording of it, and I'll make that available to everybody as soon as possible. So again, thanks for attending, and everybody have a good day.